Hello everybody. In this lecture, we will discuss about manufacturing processes for concentrates and pastes. Okay. So, the concentration process, different methods of concentration like evaporation, cryo-concentration, membrane concentration, and finally, we will take up also a few examples of some common concentrates and paste like tomato paste, fig paste and mango paste, their manufacturing process. Okay. So, concentration, it is particularly juice concentration, is aimed at removing the water and increasing the soluble solid concentration in the soluble concentrate in this. So, generally what happens when you increase the soluble solids concentration in the juices, it offers the advantage in preserving its quality. Also, you can keep it for longer time. Okay. It is the storage becomes convenient, shipping become convenient, and in fact that most of the juices etc., even for ready to serve, ready to drink juices, the practice by the industry is, because these fruits and vegetables they are seasonals. So, in the season they produce these juices, convert them into the form of concentrate and paste, and these concentrates and pastes are preserved, kept for the later on dilution and conversion, making into RTC, RTS or RTD and other beverages etc. Okay. So, juice concentration is mainly accomplished to reduce water activity of the juice product, which lengthens its shelf life, minimize packaging, storage and transport cost, and it stabilizes or simplifies the handling of the final juice products. Okay. The concentration processes may be three types: evaporation, membrane concentration, or cryogenic concentration or low temperature concentration. Evaporation, simple, that is the boiling, removal of water by boiling. Okay. Whereas in the membrane concentration, it is the juice is passed through a semi permeable membrane. There are various methods, and the membrane selectively retains certain components and solids and allows the water to go out. So, RO, reverse osmosis, is one such process which can be commonly, or microfiltration can be used for this concentration. In the cryo concentration, it is the low temperature freezing of water and then mechanical separation of the water ice crystals from the unfrozen solution. Okay. So, this is in this slide I have shown that the whole starting from the fruit receiving to the preparation of the juice and then its concentration. In the last class, we discussed the process up to juice preparation. So, once the juice is prepared in the industry, this system is same. Then from this prepared juice is sent to the concentration unit, where by any of the method which we discussed in the earlier slide, that can be used for getting the concentrate of the desired bricks. And then these concentrates are further sent for that either chilling, freezing and frozen storage, or by aseptic processing, packaging and storage at around 10 degrees Celsius or so. So, in today's lecture, now in this part of the lecture, we will basically discuss about the concentrate about the concentration process, this aseptic processing and other this post process treatment, packaging etc., we will take up separately. Okay. So, evaporation is the first method. It is the process that separates waters from the juices by means of heat energy. Okay. It may be batch or it may be continuous process. The evaporators may be single effect evaporator or it may be multiple effect evaporator. In single effect evaporator, heating medium is steam or water vapors. It is however inefficient use of thermal energy, and for evaporating 1 kg of water, about 1 kg per hour live steam is required. So, the some of the problems of single effect evaporator can be overcome, that is the by multi effect evaporator. Here heating medium is vapors from the previous stage or effect, and it is more efficient use of thermal energy in this, and evaporation of water from the juice even can be obtained at a lower temperature. Okay. So, in the multiple effect evaporators, you can see in the picture here, there is different single effect evaporators when they are put in series or in parallel. Okay. Then the put, that is in the first effect, it is the steam or hot water is used to create the vapors, and then output of the first effect becomes the input, that is the vapors. It goes to the second evaporator, and then it is used for evaporating the liquid, and then the vapors generated from the second effect is taken further to the third effect. Okay. So, in the multiple effect evaporator, the steam is only, as I told you, used in the first effect. The reuse of vapors result in higher energy use efficiency from the system. So, the partially concentrated product leaving the first effect is introduced as a feed in the second effect, and so on. So, it results in the better steam economy. Steam economy can be calculated using MV1 plus MV2 plus MV3 divided by MF, where this MV1, MV2, MV3 are the vapors produced in the first, second and third effect respectively, and then MF is the total steam supplied. Okay. Then further that is the energy and enthalpy and mass balance etc. can be found out, and steam economy and process economy can be calculated using these equations, that is the mass balance equations for the flow of on flow streams, or mass balance equation on solid fractions. Both these equations are there, they can be used. Okay. Here XF and XP are the solid fractions of the feed steam at first effect and the product stream at the last effect. So, the mass balance may be XF MF is equal to XP MV1. Okay. Similarly, enthalpy balance around each effect can be calculated using these equations. Here like MAF HAF plus MAS HBS is equal to MV1 HV1 MF1 HVF1 or MAS HS HCS. So, similarly, the superscript you can see, that is the 1, 2, 3, S and C refer to the first, second, third effect, steam and condensate respectively. H is the enthalpy, okay, of the steam. So, this is the system, different notations are given. So, these equations can be used to calculate the this HF enthalpy of the HF feed as well as enthalpy of the product, that is can be calculated using these equations. Okay, like HF is equal to CPF TF minus Tref, or HP is equal to CPP T3 minus Tref, where CPF and CPP are the specific heat content of the feed and the product. TF, T3 and Tref are the feed, product and the reference temperatures. Then these equations we have given, like Q is equal to UA delta T, it is the general mass balance equation, heat transfer equation. So, heat transfer across the heat exchanger can be calculated using these equations. So, the pressure and temperature in each effect, that is there are 3 effects, similarly there will be 4 effects, 7 effects, that is multiple effect evaporator. Then in each effect if you go, then subsequently pressure will change, like P1 is more than P2, P2 is more than P3, P3 is more than P4 and so on. And accordingly the boiling temperature also, that is T1 is more than T2 and T2 is more than T3 and so on. So, this that is the advantages of this multiple effect evaporator include, that is juice boiling at lower pressure is achieved at lower temperatures, and therefore, heat labile vitamins and flavonoids or bioactives are better retained in these processes. Here there is arrangement of the different that is if evaporator, single evaporator, the multiple, that is co-current or counter current. Like in the co-current you see the steam and feed both are going. Similarly, in the parallel also, C is the parallel also, it is the almost similar arrangement, where in the counter current that is the steam is going from this side and feed is entering from the opposite direction. So, their movement is opposite or even mixed. So, this may be a various arrangement for that to have the multiple effect evaporators. Then other evaporator is the one is the pan or kettle evaporator. These are the simplest and oldest type of the evaporators used for concentration of juices, squashes, jams and confection products. These are the, you can say, hemispherical cells or pans made of stainless steel. Heating is done by steam circulating inside these heating coils, which are made of copper. Our cells can be mounted permanently in vertical position for the product exit from the bottom of the pan, etc. So, this is the steam is coming, steam is heating here and the feed is there. So, water vapor goes out and the product concentrated juice comes out here. So, the advantages of this is that it is easy installation, easy scalability, maintenance, it is smaller capital cost. However, it is not suitable for evaporation of thermally labile heat products, because along with the water the other bioactives, particularly some heat sensitive components, may also get evaporated. Okay. Then vacuum, and so the problem of these earlier these pan or kettle evaporators, they can be to overcome to great extent by using vacuum pan evaporator. Here the same principle works here, but only thing that is by the creating the vacuum, that is even the fruit can be juice can be caused to evaporate even at a temperature of 100 degrees Celsius, etc. So, the vacuum pan evaporators operate at around 70 degrees Celsius and they are often capable of concentrating up to 200 kg of fruit juices per hour with an average evaporation rate of around 3000 kg per hour. Okay. Then rising film or falling film evaporators, you see the schematic is shown in the figure. In these evaporators, thin film of juices are passed over rising or falling plates, and this allows the evaporation process to occur more quickly at lower temperature. Okay. So, the principle of working here is that basically conduction, heat conduction, from the evaporator the heat transfer takes place, the temperature of the juice rises, increase, and finally the water evaporates from the juice. Okay. These evaporators generally consist of a number of heat exchangers and lateral concentric centrifugal separators. These are mainly used where the juice cannot endure prolonged exposure at elevated temperature. So, this type of evaporator. So, in this what is done? The juice is fed into the top of the heating tubes and this is distributed continuously into the thin films while rising or falling, the films which are rising and falling down, and it results into the quick evaporation of rising and falling films, and there is separation of falling films in the separator at the bottom. Then thermally accelerated short time evaporator, which is commonly known as TASTE. So, TASTE is a continuous STST evaporator which comprises long vertical tube of a falling film. TASTE is also known as Sabin effect evaporator, as steam is reused Sabin times to evaporate the water. TASTE operates on the principle of high temperature, short time exposure, thermally accelerated descending flow, is low steam consumption, or this type of evaporator is most suitable for orange juice concentration, other low pulp or clear fruit juices concentration, or pre-concentration of products containing higher fibers. Then effect of evaporative concentration process on quality attribute, that is one major problem or issue. Although this evaporative concentration is a good process, but it invariably, that is because if high temperature evaporation, it may cause that as I told you, heat sensitive components may also get evaporated. So, there is changes in the organoleptic quality or nutritional value of the concentration, concentrate may be opted, but there are solutions. It can be reduced when volatile recovery unit is used. So, in most of the such units there is a separate unit, volatile recovery. So, first using some appropriate method, volatiles or flavors are stripped, or volatile flavors they are collected and they are again reused, that is without they are mixed into the system. Without volatile recovery, losses of aroma compounds including esters, aldehyde, terpenes, etc. are there, and it reduces the flavors of the concentrated juices. Also, this high temperature evaporation may darken the color of the juice, and this darkening of the juice color is also partly because of the increase of the concentration of solids. Okay. There is a reduction of water activity and which promotes chemical changes like even Maillard browning. It causes to the changes to the anthocyanins and other pigment in fruit products. So, there is one important thing, that is improperly selected concentration method, therefore, may be detrimental to products sensory and nutritional profiles, and it may result in increased production cost. So, there is a proper concentration method should be used, and the proper selection of the concentration approach depends upon the nature and state of the juice and also the extent of concentration desired, because many a times that is in the concentrate evaporative concentration, if you go for generally about 25 to 30% total solids, it becomes difficult because it will be so viscous that removing it from the containers it may be a difficult issue, difficult thing. So, accordingly, the other method, novel methods for concentration may be used, and in one such method is the membrane technology. It is a non-thermal processing technology having advantage of lesser energy consumption and lesser losses of nutritional profile, especially the thermolevel vitamins and nutrients. So, it is one of the promising alternatives, thermal processing, that is alternative of the thermal evaporation, etc. So, here it is a membrane based technology, and one such technology is the reverse osmosis, but it can not satisfy the concentration normally beyond 25 to 30 degree Brix again here in the reverse osmosis if you go. So, maximum concentration 25-30 degree Celsius degree Brix can be obtained because of the increasing the viscosity of the concentrate and removing the material. Okay. So, the recent developments in the membrane engineering to overcome this limitation include the membrane distillation process or osmotic evaporation or integrated membrane separation processes, the membrane process. So, these are the processes which can be used. So, in the membrane technology, like you see that it is the principle of membrane separation is this, that is the material with the help of a driving force, that is it is separated. So, the concentrate part you get in the retentate and the water goes out to permeate. Okay. So, the membrane distillation process, that is it uses the microporous hydrophobic membrane to separate two aqueous solutions maintained at different temperatures. So, a net flux of pure water occurs from solutions at high temperature to that of low temperature. The driving force is due to difference in the vapor pressure at the solution membrane interface. So, membrane distillation occurs at a ordinary pressure and temperature that is much lower than the conventional evaporation. It is used to concentrate juices sensitive to high temperature and high osmotic pressure. So, typical membrane characteristics may be 0.1 to 0.2 micron in diameter pore size of the membrane, they may be 80 to 250 micron thick, and the porosity may range from 0.6 to 0.8. The membrane materials may be polyethylene or polyvinyl difluoride or polypropylene and so on. So, the process these include formation of vapor pressure gap at the solution and membrane interface, and then passage of vapor through the microporous membrane system, and then finally condensation of the vapor phase at the cold side of the temperature. So, this includes the working principle. Then direct osmotic concentration, that is direct osmosis. It is even sometimes it is a common practice, osmotic concentration of fruit juices. Okay, DOC, it operates at a low temperature and pressure. In DOC, the osmotic pressure gradient between fruit juice and solution of osmotic agent is maintained across a semi-permeable membrane. Therefore, water flows from the single strength juice to a hygroscopic, non-toxic, inert that osmotic agent, and that does not affect the taste, color or odor of the juice product. Generally, the solids of smaller molecular weight when present at higher concentration offer higher osmotic pressure. it is capable of retaining the original flavor and sensory characteristics of the fruit juices. They are the ROC, that is in this slide we have shown you the arrangement, that is a DOC process where that it contains direct osmosis flat module or membrane, this one, and then it has well valves, peristaltic pulp for putting the, for sending the juice, feed reservoir, osmotic agent reservoir, and balance, etc. And these are the membrane modules shown in the B, DOC membrane modules, and the mechanism of direct osmosis, how it occurs, I already explained it in earlier slide. So, basically water transport from the solution of low osmotic pressure to the solution of high osmotic pressure. So, this is basic mechanism. In this figure, pi 1 and pi 2 are osmotic pressures of feed and osmotic agent solution, and P 1 and P 2 indicate feed side and osmotic agent side hydraulic pressures. Then reverse osmosis. It is a common, very common method even now used. You know that if the pressure exerted, now osmotic in the earlier slide you have it. So, reverse of that, it means that is the osmotic pressure, whatever the osmotic pressure, you have to apply a pressure gradient more than that of the osmotic pressure. So, then the flow can be reversed, okay, in the opposite direction through the membrane. So, RO has been used for concentrating juices of peach, pepper, apple, mandarin, and so on. Soluble solid has been found to increase from even 12 to 30% or even 21 to 30 degree Brix, etc., under 4 and 2 MPa transmembrane pressure, etc. Of course, what is the these juices and what are their various solutes which are present there, they will contribute to the final osmotic pressure, and accordingly what should be the overall pressure, that is what are the membrane characteristics and all these things, transmembrane pressure, that will govern the process, and that will depend upon the characteristics, etc. So, in the reverse osmosis, basically theories of the solute and transfers, there are recommended are, that is preferential, it may be preferential Sargent theory, where solute and solvent pass through the membrane by diffusion, okay, or it may be solution diffusion theory, where solute and solvent are first absorbed on membrane surface before passing through the membrane. Okay. So, the major problem in the membrane concentration process therefore is the leading factors leading to the reduced flux, because there may be concentration polarization or pore blocking in this, and this accumulation of solids at the membrane surface. So, increase in the osmotic pressure or concentration polarization impact, etc. So, this may result in the reduced flux. So, what are the possible solutions? That is alternating or altering the operating conditions of the, such as feed pressure, concentration, temperature, cross flow velocity, or promoting the turbulence, or back flushing or washing, or pulse flow, etc. Some of these potential measures to increase the flux rate. Then osmotic evaporation is another method. In osmotic evaporation or in osmotic distillation, it is a hydrophobic microporous membrane is used to detach two liquid phases that differ greatly in terms of solute concentration. The microporous membrane works as a physical support at the vapor pressure interface. The evaporation process accompanied by simultaneous heat and mass transfer, and the overall permeation rate is decided by membrane properties, operating conditions, mass or heat transfer, etc. So, in particular, this technique best fits the situation encountering thermally labile and volatile coloring and flavoring agents such as fruit juices, etc. So, for this concentration of such material, osmotic evaporation becomes a better process. Then next comes the cryo-concentration or freeze concentration. Particularly, again this is suitable for the material where that these which contain to get, in order to get a better quality, particularly better sensory characteristics, color and flavorings, or bioactives, their presence in the component. Okay. So, the cryo-concentration is an effective way to concentrate biological materials without harming their integrity. It involves removal of pure water, that is, so that is the freeze concentration. So, first it is lower temperature, we have discussed earlier the freezing process. So, water, whatever water, free water is converted into ice, and then this ice is removed either by concentration, either by crystallization, after the crystals are separated by centrifugation or by filtration or by appropriate methods. Okay. So, the components of single stage cryo concentration or freeze concentration unit, there are two important components, crystallizer and the washing column. The crystallizer, basically in the crystallizer here the ice converter, that is the low temperature is maintained. So, whatever water is converted into ice, and basically scraped surface heat exchangers are used, SSHE are used, and they are encapsulated with cooling coils or circulating refrigerant structure to, in order to facilitate the conversion of water into ice. And then this concentrated liquid is separated efficiently from ice crystal using this separation column, filtration, centrifugation, etc. So, these system advantages are the maximum retention of original product characteristic, there is no or little loss of the taste, aroma, color, nutrients, etc. Higher concentration level achieved than the reverse osmosis in this. This is disadvantage. However, if the lower concentration level achievable than boiling under vacuum, very high capital cost. One of the major challenge here is the very high capital cost, is a large energy consumption, or even sometimes phase changes can be detrimental to the nutritional and sensory characteristics. But this freeze concentration is commonly used, it is used by the industry, particularly for high value commodities, etc. Okay. Then progressive freeze concentration, PFC, it is an exceptional modification in conventional process. It avoids capacity constraint and nutrient losses. In PFC, scrap surface heat exchangers are replaced with more efficient spiral exchangers. So, in PFCs, crystals are deposited in the form of layers over one another on the cooled surface of the large surface area, that is spiral fin, which exceptionally reduces the capital cost and undesirable changes in the concentrate. Then this pressure shift nucleation or cryonucleation, another emerging technology that is using higher pressure shift freezing or concentration nucleation. In PSN, commonly known as PSN, ice nucleation is avoided while cooling the liquid to sub-zero temperature at high pressure. So, at sudden pressure release would include a uniform sugar cooled liquid that would crystallize thoroughly rather than on the surface of the liquid, as happened during in the conventional freezing. So, in the pressure shift freezing you get that is even a large number of ice crystals of uniform sizes, etc., and this becomes, that is advantage of the pressure shift freezing is that it is easier to set temperature of a high pressure vessel than that scrap surface heat exchanger. There is no need of complex scrapping devices, thus energy is saved. Crystallization takes place in whole vessel, no need to recirculate juices to increase size or volume of ice form. Ice crystals grown during expansion are round and free of pockets and scoops. It retains and stabilizes thermolabile food products, and use of high pressure can initiate microbial and enzymatic loads, etc. So, whatever the problems of the conventional freeze concentration process, like the ice crystal is formed at the cold surface, these are okay, or they are less efficient, or ice crystal may have the pockets and scoops which might be occupied by concentrated juice. So, all these problems of the conventional freeze concentration systems are overcome or removed by pressure shift nucleation system. Now, let us see the tomato paste. It is a very commonly used commodity. It is extensively prepared because the tomato, in the season, it creates gluts, but when it's out of season it becomes scanty. So, this when this season, this juice is converted into paste, and this industry stores this paste in a suitable form, and later on it is the paste is used for making ketchup, making sauce, making ready to serve juices and so on, tomato soups, etc. So, according to Codex Alimentarius, tomato paste must contain at least 24% tomato solids on a salt free basis. Tomato paste is made by de-seeding and de-skinning the tomato and cooking the concentrate or concentrating them for several hours. So, normal process conventionally used are thermal evaporation, but the fridge concentration, membrane separation like ultrafiltration and reverse osmosis, okay, are the potential process. They can be used for making the paste, and these processes will give a paste of better quality, and even sometimes the industry uses application of some permitted thickening agents to improve the consistency of the products. This is the process flow chart, which is a conventional process flow chart like tomato washing using the potable water, sorting and trimming, and then blanching at 90 degrees Celsius for 3 to 5 minutes. So, this inactivates the enzyme, and also it fuses, that is the known as hot break method for the juice extraction. So, it gives the better yield of the juice. So, then pulping and staining and the cooking to desired consistency, that is double jacketed steam kettle or vacuum pump is used. So, here this tomato is concentrated. So, finally, judging of the end point, the TSS of the puri, that is the puri is around 12 to 15%, or if it is paste then about 25%, and this is done by hand refractometer, or volume is measured by the measuring stick. So, finally, once it is a desired consistency is obtained or end point is obtained, then this is filled into hot and sterilized bottles or can at around 82 to 88 degrees Celsius, and finally, the lids are properly sterilized lids are sealed, and then it is sealed, and sealed bottle is boiled in water for about 20 minutes, etc., cooled and then stored. But these conventional process are now, that is even aseptic filling, aseptic processing will be more convenient, better if it can be used. Similarly, here the fig paste, conventional method for the making fig paste, selection of the fig fruit that is mature with a bright color and characteristic flavor, etc., should be used. Then common process like sorting, then washing and cleaning. Here the washing and cleaning may be the rinsed with chlorine dioxide, maybe 10 to 100 ppm. Then aflatoxin checks should be there under UV lamp, whether there is any contamination with fungus, etc. Then metal detection, grinding. Finally, this pulp grinding, you get pulp, and then in this pulp they add about 0.05% sugar and double rate of and soya protein isolate and preservative at the around at the rate of 0.05% sugar and soya protein isolates, etc., and this is then mixed into a colloidal milk for colloidal mill for uniformly mixing and homogenizing the things, and it is boiled with scraping, that is 100 degrees Celsius for 5 to 10 minutes, and then finally bricks is set to around 70 degrees Celsius, and the rest is the hot filling and sealing, or it can be preferable it should be done aseptic filling and packaging. Similarly, the mango paste pulp, you can see here in the process, in the similar process is used like receiving, then bubble forming and juice extraction, boiling before measuring, then juice extraction per tank, and this homogenization, degassing, and finally concentrating, and this pulp can be is packed. So, for packaging, even aseptic processing, because in these juices, in these concentrates, if this storage, if they are in the storage environment in the packet, if there are the head space gases, oxygen, etc., it may cause the some oxidative changes, color and sensory characteristics, etc. So, it is recommended that yes, it is better that if aseptic processing and packaging system is followed, that will give the better shelf life and better quality of the product, and this aseptic processing and packaging etc. we will take up separately for these things. So, finally, yes, I will summarize that obviously you know that these juice concentration, that is converting these fruit juices into concentrate or paste or even the fruit slices etc. into the pulp and then storing them in the form of concentrates, pastes and pulps offers the advantages of lesser storage requirement, okay, longer shelf life because the water activity is reduced in these pulps and concentrate. However, there are certain challenges, that is the evaporation process or that is conventional evaporation process as far as possible should be avoided, and novel technology like membrane separation process, freeze concentration, although this freeze concentration may be little costlier process, but the advantages which one gets, this definitely overcome the disadvantages, economic disadvantages of the process. So, I recommend that one should go for the freeze or cryo concentration or membrane concentration, because these fruit concentrates, juice, paste etc., the valuable component are bioactive, that is they are known for this. So, every possible effort should be made to preserve these bioactives as well as sensory characteristics, sensory components of these concentrates and pastes. So, these are the references for this. I thank you very much for your patience.